The motor effect. The motor effect is what happens when current and magnetism interact at right angles. They produce a force. This force is at right angles to them both. So this is just like in maths when you get coordinates in all three dimensions. You'll hear a lot of teachers, the thumb is a force, it's a force. The first finger represents the field, Fi, first finger. And the second finger is only with a C in it, it's the current. Magnetic field goes from north towards south. Conventional current goes from positive towards negative. So thumb is thrust. So a simple description of a motor is it transforms electrical energy into kinetic energy. This is my model of a motor. Okay, and it has several parts that you need to remember. The central part is called the block. You see that the block freely rotates around an axle. Okay, this coil of wire here, you have to remember, this is called the solenoid. And these two magnets are set on attracting, and they are my magnetic field. So what I'm going to do is I'm very quickly going to make a motor. Okay, this exposed piece of wire that I'm leaving at the end here is my brush. Okay, that is called the brush. It's just a contact, electrical contact, and it's just an exposed piece of wire, that's all. Strip that last little piece of wire. And that's the block and the solenoid already. Then what I need is my magnetic field, and the motor is actually made already. So if these are the brushes, next I need my slip rings. They don't really need to be slip rings. What I'm going to use are just the bare exposed pieces of wire. And as the motor spins, the brushes touch one of the split rings and then the other. See if it works. And you can see my motor goes. The ways in which I can make this a more powerful motor, a stronger motor, increase the force that I get out of this motor, are by increasing the number of turns in the solenoid. I can use a stronger magnetic field across here. I can increase the current I supply, and I can increase the actual size of the coil, not how many turns, but the actual physical size of the coil. Some of the ways that we can use Fleming's left-hand rule to know things about these motors. This red wire, this is the positive wire, this black one is the negative wire. I'm going to turn this on a really low voltage here, so I just want to see which way does it initially move. So on this side it's moving upwards towards the camera, so that's represented by my thumb. It's represented by my thumb. And I know as well, from positive to negative, all the way around, but from positive round to negative, the current must be travelling in this direction here. So I need to orientate my second finger direction of the movement. Then finally I can put out my first finger in the direction of the magnetic field. So that means that this must be from north to south. Another reason why I think people don't do very well in their motor questions in their GCSEs is because they like to draw very simplified versions of the diagram. In the motor you can clearly see it's a coil of wire, whereas they have chosen to draw simply one wire around. You don't need to worry about that, you just need to make sure you're ready with your left hand rule, and you can identify which direction is the current on each side of the question. This question is a very good question. It actually asks you whether it's an electric motor you're using or a generator. So let's just see if we can understand this. So you know that your first finger is the field, it's in the direction from north to south. The second finger is the current, so on this left hand side the current is towards that direction. So if it was a motor, on this side it would be moving down to the left. Okay? Or on this side, if I reorientate those, so the current is now in this direction, notice the field is still in this direction, moving up on this right hand side. If it was a generator, however, then the directions would be different. If I get my second finger in the direction of the current on this side, orientate my field from north to south again, you can see this time it will be moving up in this direction. Okay, and the other way around, field still stays the same, we're moving down on the other side.